Hi, and welcome to the AI Sweden 2025 Trend Seminar. We are so happy to have you here. We have even more signups than last year when you saw me and Daniel in the frame. My name is Astrid Sjögren, and I'll be moderating this event. And with me here, we have our trusted expert commentator.
Oh, thank you.
Daniel Lillblad, who is the Senior Advisor for AI Sweden, as well as Chief of AI at Recorded Future.
Correct.
So happy to have you here again.
Great to be here again.
And in today's agenda, we have a number of interesting topics lined up for you. We'll be starting by talking about the main theme of the event, collective intelligence, and then we'll move on to talk more about agent-based technology, safety and trust issues related to this, as well as the implications for business strategy. And after that, we'll look into the job market and the shifts for employment in general. And then we'll be finishing off by talking about the geopolitics of AI. So let's all get into this. And we'll be starting off by giving you the floor, Daniel. So take it away.
Thank you very much. And again, great to be here again. A lot has happened in the last year, and it's a really great opportunity to follow up on some of the things that we did talk about last year, but also looking even further into the future and current developments. And what we're going to talk about today, collective intelligence, is of course a consequence of the fact that AI today is almost in many senses a commodity. We have such strong models that are gaining almost superhuman capabilities in area after area after area. And with the latest developments of models that are actually reasoning when we ask them a question and actually sort of talk to themselves about how to solve a problem, results have really started to shoot through the roof, even in more complex scenarios. Combined with using external tools, integrated new data sets, etc., this kind of capability is something that is just starting to see actual real use at scale, but it will be there. However, one of the things that we typically talk about when we talk about these models and these developments and so on is that sometimes we tend to talk about them in a little bit as monoliths. This model does this model does that. This is a photo of a very old textbook, and it's a very old photo from an old presentation, but I really like the title of the book, basically. It's called Society of Mind, and essentially, this is what we're going to talk about today. How do we build smaller systems, or perhaps relatively large intelligences, that actually start talking to each other to fulfill something bigger, actually solve real tasks? And of course, this is something that some of these foundation models already start doing within themselves, but we're definitely seeing a development to, if we want to get real value out of these things, we need to build them into other systems. So here we come to agent systems. So here is a little bit of my take as both a researcher and a practitioner. Agents in 2025 is a little bit like, this is the practical approach to actually leverage some of these technologies to gain real value out of them, both in terms of natural interaction, but also actually automating things, actually accessing all the different data sets that we need to incorporate, accessing all the tools that we need, it might be physical simulators or other things that they need to use to actually find out objectives or results. Basically, agents in 2025 is the practical approach to scale these kinds of systems to real value. And we can see that they are really starting to redefine software. So we're already seeing companies building these things in-house, where we have software processes talking more or less natural language to each other and going back and forth, which is fantastic. We are starting to see that it might actually start to commoditize some of this, for example, software as a service companies and so on, because all of a sudden, rebuilding some things becomes so much easier, and it's a much more difficult task to stay unique. And another thing that's happening in the background is that for all the systems that we've built so far, interfaces are changing. when we have agents actually performing tasks or talking to each other in the background, computer interfaces become something completely different, and in some cases almost disappears. So this is quite a big change, both for existing companies, but also if you want to build new services and technologies for the future. So if we're looking at, for some of the approaches that personally I've been working with and that we've been working with within AI Sweden, everything stretches from very, very simple stuff, simple workflow automation. You trigger an agent basically on very, very simple things. It might be a question, or it might be a time, or something like that. Helpful, but not all the way there. Then, of course, we have agents building more and more on actual self-planning and execution of tasks, but with humans in the loop. But more and more, I think a lot of companies and a lot of organizations are actually looking at how do we build them fully autonomous? So if we actually want full automation, what do we need to do? And an interesting thing here is that sometimes it's easier to actually go from nothing to full automation, in a sense, than go through human interaction, because we can actually build solutions that are not human explainable or interpretable in any sense, but they work anyway. And that, of course, this means a lot. Going towards autonomy and automation means that perhaps we need to talk about these things a little bit differently. We need to build these kind of agent systems and integrate them in everything we do to get these kind of productivity gains that we really want. But that also sort of means that we might not just be automating tasks anymore, that we've been talking about in this AI sphere for a very long time. But perhaps we're actually starting to remove some job descriptions. What does that actually mean then for the workforce and the integration of these type of AI technologies? So these are some of the things that we're going to talk about today. How do we build these things? What will it mean for services, for research and development? How do you use this to build research and development semi-autonomously, etc., etc.? Of course, if we start to go beyond one organization especially, and actually have agents talking to lots of other agents across organizations, how do we address safety, security, basic stability of the system so that doesn't go do something really, really stupid eventually? And today, in 2025, with the last months and last weeks even of developments, it's difficult to tackle these issues without actually at least touching the geopolitics of AI. So where will these things be built? What principles, and who gets to use them and how? And we will talk a little bit about that at the end of the seminar. With that, I think it's time to leave the floor to some of our guests.
Indeed it is. Thank you for that spectacular introduction, Daniel. So we're going to be staying on the topic of agents right now, and we'll take a little visit to our fellow partner AstraZeneca and the pharmaceutical industry. And for that, we welcome Magnus Nydén, who is the head of innovation at AstraZeneca. And the floor is yours, Magnus.
Thank you so much. First of all, a big warm thank you for the invite. It's a great opportunity to be able to share more widely what we do in our company. I'll talk about something today that we called AI-powered drug development. I lead that program. I think it is fair to say it is the largest AI holistically combined program in our organization at the moment. We talk about digital development end to end. You'll be the judge of that today, I guess. But I wanted first to give you a very brief introduction as to why we are doing it. First of all, from a company level, and then down to the more specific level in the area where we're actually looking at implementing some of this. So first of all, why? Our CEO has clearly pointed in a direction where we, for our patients, need to deliver 20 new medicines by 2030. And we're going to have a very hairy target on growing to 80 billion, which is almost doubling the amount of money, if you like, than what we are currently at. But we can't do that by growing our workforce in the same way. It is simply not sustainable for us in the long term. So what I've been tasked with is to come up with solutions for that. And at the same time, we are also going carbon negative in our manufacturing of medicine. So those are really, really bold aspirations, and we need help. And one of the mechanisms that we are utilizing for that help is AI. as everyone else these days. So what I'll share with you next is the layer at which I'm active, which is in pharmaceutical technology and development. We're about 1,500 people. We design, develop, and deliver the new product pipeline. We generate data required for regulatory submissions. We also have on-market technical support for already commercial products. And we importantly manufacture and supply clinical trial materials. So what does that mean? We're not in the business of discovering drugs, but look down on your left. We're in the business of taking those drugs, molecules, turning them into molecules, medicines, apologies, turning molecules into medicines. That is a highly complex piece of machinery, and it relies on mechanistic understanding to a very large degree, not on data-driven models. And I'll come back to that in the end. That puts an extra requirement on the way we use AI. The next thing I'll say here is that a couple of years ago, I kicked off a training program so that now 10% of our whole workforce are called AI ambassadors. So they've had a couple of weeks full-time training in digital twins, in machine learning, specifically in AI in general, and also specifically in generative AI. And on the back of that training, we have a number of ideas that we have collectively put together in a big program that we now call the AI-powered drug development program. This is a program with 3 phases. I love what you talked about before, Daniel. It is very similar to what we are proposing. We call the first phase of AI-powered development the automation phase. This is where we simply do things we know the AI, the LLMs can do today. We automate generation of documents on the back of new information coming in, but trained on previous documentation. We're a highly regulated business. Our documents are of very high quality, but we have so many of them. So our main challenge here is to get our data house in order to feed the AI with the right type of information. The second phase of this program, which is a couple of years later, although fully grown a couple of years later, but we're already starting now, is what we call the assist phase. This is where we have our scientists interacting with the mechanistic models in a different way. And I'll show you an example after that. It's a very small example. I'll hopefully give you an insight of what that means. However, the third phase is based on a hypothesis. I should say, we already know we can do the second phase. We just need to build the system and the data and the business processes needed to underpin it. But the third phase, the recommender phase, relies on a hypothesis that our models are getting more and more cognitive. Daniel talked about reasoning. They need to be reasoning much better than they are today. But we see a path towards where that is happening. And what that means that in a few years' time, we believe we can use them to recommend for us the best paths forward. Before I embark on the actual example, I'll say this. I don't see a future in the near future even where we will let an AI, a generative AI, for instance, produce a material for us that we will just submit to our regulatory affairs colleagues in the various countries. We will always have the human, not only in the loop of the process, but as a final say for quality control. This is very important. Fundamentally, anything we do have to be safe for our patients. And we need the human in the loop as well as the final decision maker. But we believe that the AI soon can recommend best path forward for us, not only to make our medicines in the best possible way, but do it also with low carbon footprint, as well as all the other aspects underpinning a very efficient medicine. So let me bring you into 2030. So imagine that you are there now. You work in the pharmaceutical industry, more specifically in pharmaceutical technology and development, where I am, where your task is to develop the route towards taking a molecule and turning it into a medicine. So this is an example of a scientist that says the following. I have a solution of an AstraZeneca molecule that I need to crystallize and isolate, because that's an important first step when making a medicine. The final particles of this molecule will be used in what's called an instant release tablet formulation. It's simply a tablet that dissolves in a particular way. And it must match the minimum AstraZeneca requirements for tablet manufacturing with one of our technologies that we make. Doesn't matter. Please propose methods for crystallization and isolation to achieve this target. In addition, seek to minimize the sustainability impact of the methods, provide a step-by-step explanation to your conclusion, and provide references to internal as well as external literature for each decision. So that query goes into the system that we are now building, the AI-powered drug development system. So the first thing that happens is that the business process agent and other agents are trained by external and internal data. External data from the literature and everywhere else we can find high quality data that our scientists have said are key data for the decisions that we are now talking about that needs to be taken. It is also trained on our internal business processes, and they are very important because we're a highly regulated business, remember I said? So the path from a drug to a medicine is very highly regulated, well described, and the ontologies are correct, so the words are exact, etc., which lends itself really natural for LLMs in the way that I'll be talking about now. So what happens then? Well, the scientist forwards the requirement to the business process agent. The business process agent designs then the flow through the whole value chain. The business process agent checks if all requirements are in place. Are they available? Either from the prompt or from previous reports from this particular project. If it isn't, the business process agent requests the information from the scientist. But then, if it has everything it needs, it believes, it forwards an ask to the materials agent for AstraZeneca standard requirements for a particular piece of equipment. It may relate to the chemistry of our excipients, or it relates to the settings of our instruments. But also references then are required, and that we're asked to return those references. Then what happens is that the materials agent goes back to the business process agent. It asks the material agent for, or the chemistry agent for whatever requirements might be used, and it instructs the chemistry agents to optimize with regards to stated boundary conditions. What then happens is that the chemistry agent calls the models that you will see underneath here. It will call the crystallization model, which is a mechanistic model that talks about exactly how these things mathematically underpin the material science parameters with the outcome of those parameters in terms of this model. And it loops back that, and it does it potentially several times. It reports back to the business process agent. And then that's a best process solution. It asks, is this acceptable process parameters? Are they in the acceptable range, etc.? And then it might go back to the materials agent for more in-depth information. And the material science agent will call up its mathematical models that are underpinning here. You see the CSP model and the solubility model that are not data-driven models, but they're actually mechanistic models. So underpinning physics, clearly understood, etc., which is important because the closer you come to patients, the regulator is interested in us having the physics understanding of the models that underpin the things that we are talking about here. And then it goes back to the business process agent. It says, I'm now done. I have a final proposal. It sends back that proposal to the scientists and reports back. These are the best process solutions, acceptable process parameters. The first study report is generated automatically. The second study report is automatically generated, etc. So essentially, this replaces a lot of the experiments that we're doing today. We call this a holistic digital twin because all of the previous experiments have now been turned into knowledge in our agents. It's been turned into knowledge into our models, so that the fact that an LLM is cognitive enough now to interact between these agents gives us the possibility to go digital first in our applications. We will, of course, use experiments many years in the future, but fewer and fewer of them as we're moving forward towards building this system that I'm showing you here. And of course, collectively, agent-wise, who knows what will happen once we start to maybe even fine-tune a model on the back of the information that we are continuously generating here. That's one of the things that we are, of course, looking into. So that's a very brief view into how we see the future in AstraZeneca. I think I'll leave it there, and happy to answer any questions, and of course in the panel later.
Thank you very much, Magnus, for that extremely interesting presentation. So we're going to spend a couple of minutes because I do have follow-up questions for this. So as you say, AstraZeneca, you're in a very regulated business. Quality and compliance is non-negotiable, of course. And I bet there's a lot of people in other regulated businesses watching, and some of them might be a bit concerned, not only for the regulation, but also for the probabilistic nature of language models and generative AI. That's, they do hallucinate. So, but you haven't shied away. You're actually, invested in this. So what is your message to the ones that are listening?
Okay. These things are evolving quickly. I think it's very important not to look at what's here and now, but how things are evolving. The hallucination issue is likely going to be an issue for a while, but we also see how it can be made almost redundant by a collection of techniques, such as, you prompt well, but you RAG well, you have your data house in order, you contextualize your data. All of these things together, in our experience, it's not a big of an issue as I thought it would be. It's also important that's why I pressed the fact that we're in the business of mechanistic models to a large extent in my neck of the wood. Earlier, when drug discovery is talked about, they have data-driven models to a larger extent. So the probabilistic nature potentially is more of a problem there, although I'll leave that to my drug discovery colleagues to talk about. The probabilistic nature here with what I've shown you is more in the LLMs themselves and reporting back and so on. But for reasons I just talked about, I don't think that will be a game-changing or an aspect that will prevent us significantly in the future.
Yeah, this is a very interesting point, and I think it's something that many people run into. Actually, some of these perceived problems with LLMs and these kinds of models, yeah, they're a challenge, but you engineer them away. It's a big software engineering project. It takes some time, but you can get there reliably, which is absolutely fantastic.
Can't talk about the details, but we have examples where we've seen that the LLM produces better first draft materials than our scientists do in some area. If you prompt it correctly, you organize your data correctly, categorize, contextualize, etc., it works.
Yes. Yeah.
So that kind of leads me to the question of how far do you see these agents scaling? I mean, what you showed us reminds me at least much of an organizational chart where you have a leading manager who hands out tasks and then different units creating the tasks. Maybe we can start with you, Daniel. How far can these agents go?
Oh, I'm not sure there is a fixed limit, basically, but I think it's a gradual building process. It might be very, very good in the beginning to come to some kind of end-to-end solution that you can actually solve the tasks that you're aiming for, but then it's continuous engineering in every small piece of the process, basically, to make everything better and better and better. And I don't think we should underestimate that, but it's perfectly doable.
Wonderful. Magnus, any comment from you on that?
I absolutely agree. The agent systems are going to be built out. Need to figure out how they best communicate with each other. When you need a small agent, when you need a large agent, is that the cognition level of them, etc. But I can see some real benefits just by the individual actions with an agent and a business process agent. But collectively, who knows what's going to happen? I can only see advantages with it, unless the probabilistic sort of nature behind it causes some problems. But to Daniel's point before, I think that will be engineered out, that problem as well.
And now, professionally, I tend to work a lot with small and medium-sized businesses, so that's a perspective I bring in. And all of this testing and experimenting and data management, of course, it's expensive, especially with these large data sets. How can smaller organizations do all this and catch up?
Yeah, that's a really, really good question. We saw when we upskilled our folks, that's when things started to happen. The best ideas came from there. Even small and medium-sized businesses will have champions that will drive this. That's an important aspect. If you want to game change things, you need four things. You need the technology to do it, you need the people to do it, you need the data to do it, and you need your processes to be aligned to it. If you get all those four things right, as a company independent of size, you'll do it. The main challenge I find is to get your data house in order, which is why I've engaged at the national level for programs that help small, medium, and large corporations for tech that can help companies automate their data houses, if you like, for automatic contextualization, etc. Because this, as someone said, AI is a hungry beast, and the food is data, and you need really good contextualized data. And I think in the country Sweden, the best thing it can do at this point in time is to organize and structure data at scale.
Yes, thank you. And speaking of the Swedish perspective, I wanted to ask you, Daniel, like based on this, what we heard about agents, how can we in Sweden stay competitive? And what do you think we should invest in?
I think we should invest in things like you do in AstraZeneca, actually building applications on top of these things at scale. Not necessarily worry too much about building the full technology stack under and so on, but actually utilizing it for what we know best. And of course, again, that's building on our unique data, on our unique tools like you have in simulators and so on, our unique knowledge, our unique organizations. You said, you break down an organization chart and stuff like that. That's the kind of stuff that we need to, at scale, start building, basically.
Very good. All right. So I want to thank you very much for this enlightening presentation and Q&A. And it's time for us to move on to the next agenda point. And the topic now is going to be security and trust. So I'm very happy to invite Rebecca Ångström, who is the principal researcher of Ericsson Research and affiliated research fellow at the House of Innovation at Stockholm School of Economics. And she will be joined by our very own Mauricio Munoz, who is the senior research engineer here at AI Sweden. So welcome to the both of you.
Thank you. Thank you so much.
Thank you.
Wonderful to have you here. So we're going to kind of tag along on this agent topic, but give it the perspective of trust and security, because we see that as such important topics going forward, and something that I think a lot of people are thinking about. So now we see that with agents becoming implemented, the most common thing might not be humans talking to AI, but in the moderate to long run will be AIs talking to AI, just as Magnus showed us. So what do you think that's going to entail for our trust in systems?
Can I
Rebecca,
start?
go ahead, yes.
Well, I think that even if we don't see the system or the AI or the agent behind, still trust will be such a key important thing to make this work in an organization. Because we have people who will be reliant on the results of these systems or the processes that they perform or the tasks that they perform. So in a sense, if you have the scientist in the AstraZeneca case, that scientist will still need to trust the output of that whole system. And I don't see that this is going to go away. If we don't build trust for these kind of agents that we put in use, we are instead going to see a lot of rejection and disuse of these systems, which will just stall the whole implementation phase.
Yes. So what factors do you think are important then to build trust, Rebecca?
So when you're looking at the factor for trustworthiness in humans or in teams and in organizations, there are usually the three ones. It's the ability, that is the skill and the competences of the team or the person or the organization. It's the integrity, that you abide by the same kind of principle of values. And then you have the benevolence, that, that I want to do you good. For AI system, it's a little bit different. Usually we talk about functionality, reliability, and helpfulness, but it can also be transparency. And it also depends a lot on which task. What we're looking now into research is more also understanding that for building this kind of trust towards AI systems or agents, you need to also understand the social context, because it's a social technical aspect to this. So what is happening around you in the organization? What are your managers saying? What is the developer behind this and the supplier behind this? So there's a lot of different factors that impacts trust in AI.
Yes, and I think that is a very interesting topic, because that kind of leads me to think, do we consider flaws in machine and AI differently than flaws in humans? I don't know if you have a comment on that, Daniel.
Yeah, well, absolutely, we do. I think that, at least in my experience applying some of these technologies over the last 20, 25 years, yeah, in many situations we have a much stronger demand on precision and exactness and correctness in these methods, basically. But sometimes when we're working with these types of generative models and things like that, we might have to let that go a little bit. But I do think that some of the transparency is actually quite important, to actually be able to see what these agents are talking about, so that we can understand what's going on in the system, etc., etc. Such small things might actually build trust. Even if things go wrong, you can see why they go wrong and why they do things that they do. So there are ways around it.
Yeah, but the question is then that when we have a lot of agentic system talking to each other, will we actually have that transparency? Will we, maintain the overview? And do we even actually need to? I kind of want to invite you, Mauricio, to the conversation for that one.
Yeah, sure. So I think, to be honest, I mean, we've never really had total insight about sort of like what's going on inside of these models. I really don't expect that to change. I think the best that we can do is to figure out where the limitations are as the systems keep getting more and more complex. And I think what's critical about this point is that those limitations might not be the limitations that we think the models have. And I think one sort of aspect that underpins a lot of the discussion at the moment, and a lot of my thinking in particular, is a very specific application of something that's known here as Moravec's paradox, which is what we see when we sort of interact with these systems, for example, LLMs, that they can do very complex tasks, right? And this is, for example, what drives a lot of the investment and a lot of the discussion. But at the same time, what's also quite predictable is that there are very many cases in which they will fail, where it's about very simple logic, right? It's about common sense, and they're unable to sort of deal with this. And so I think this is something that drives a little bit this discussion also about trust, is that with the human, typically, if you can execute a more complex task, you would assume that they can also execute simpler tasks, but that simply doesn't apply to AI systems. And I think that's at the root of what sort of underpins a lot of the mistrust, I guess, that we as a society currently have in these systems.
And I want to kind of volley that back to you, Rebecca, about the distrust. Do you think it's actually necessary for us to have a bit of distrust, or is it a hindrance to value creation?
No, I actually think that distrust is necessary. And I just love the example that Mauricio is bringing up. I think when the LLMs were new, the ChatGPT and such, when you ask them to just do 2 + 2, well, it can predict that, it's most likely to come a 4 after that. But if you do ask it to raise 2 by 22, then, it gives you something completely gibberish. And people don't really make that difference, that this model can do A, but maybe not B. And when it comes in terms of trust, I think it's and distrust is quite interesting to connect this, because if we don't have that distrust, actually questioning the model, whether or not it's able to do that, it has the ability. If we only have trust, we are at the risk of coming into a situation where you have over-reliance to a system, when you start using it in a faulty way, or you expect too much, and it starts making problem for you. And the interesting part about trust and distrust is actually it's not the same construct. It's not that if you don't have trust, you automatically get distrust. It's actually activating different parts of the brain. So what we're seeing is that they coexist, trust and distrust. So if you have the right balance of trust, you will see people start using the system. But at the same time, nurture a little bit of distrust at the same time. So you question some of the results and question some of the tasks that you decide or you want to try to use it for. So you don't just rush into it and have this kind of over-reliance to a system. So a little bit of distrust is always good to have.
Oh, that actually makes a lot of sense, because then distrust isn't actually the thing that prevents you from taking action and using it. That's a whole different question, but distrust is a healthy part. I learned something new from that. But I think many of you have seen Sweden being in the media a lot for having actually lower trust in AI systems and more like tend to focus on risk compared to many other countries. So do you think, that has an impact on how organizations behave, on how we treat AI when there's a difference between countries of how we see AI? I'm going to hand that to Mauricio.
Yeah, I mean, I think the perception is certainly one thing. I think we'd have to double check the data, what that actually says in terms of adoption, and what the perceived risks are and how people sort of like navigate that uncertainty. I think we would have to take a look very specifically at that data to see what's really going on. But the perception, I would say, is that you have, of course, as in every other technology wave, you have early adopters as well as you have laggards, right? And this is no different. So I think there are, particularly in the West, right? I think we've adopted this attitude towards AI with sort of like this over cautiousness. This is something that, for example, we don't see that much in cultures like Japan, right? I mean, culturally speaking, especially in terms of robotics and robotics applications in society, I think they're on a completely different perspective, have a completely different perspective than we do. So I think it's quite interesting to observe that there definitely are cultural differences, and this basically informs the bias that we have as humans towards these technologies. And we can't simply ignore this as we consider how do we increase trust, or how do we want to increase trust, and how do we want to increase adoption. We need to basically have that self-awareness in order to be able to navigate the uncertainty, right, that arises from for example, this Moravec's paradox that I mentioned, right? Of how do we sort of put these technologies in relation to, for example, how humans think, right? The fact that we really can't map it one-to-one is a lot of the cause of that uncertainty, and we need to somehow be very cautious and conscious of that uncertainty to be able to really adopt AI at scale in society, I think.
I'm going to hand that over to you because I believe you might have a comment as well, Rebecca.
Yeah, so, well, trust and distrust towards AI is found around the globe. We did one study looking into AI implementation a couple of years ago, and one of the major challenges for implementing AI in organization is actually the cultural aspects, where people were worried about losing their job, worried that their expertise would become out of date, also worried that they would be less in control. And we saw that in that study. We did that in China, India, Germany, UK, and the US. And that kind of worries was present in all the different markets. In a more recent study we just did at Consumer and Industry Lab, we were looking into different AI scenarios in 2030, 2035, and we were targeting early adopters around the world. And this was people who have already started using virtual reality, augmented reality, generative AI on at least at a weekly basis. So they were quite advanced for that time. Is half a year ago, I think. And what we saw there is amongst this group of early adopters, you tend to believe that you will have only tech optimists, that they're super excited about the future and really looking forward to everything. Well, that was the majority of the sample. Around 50% of that early adopters were super excited about these different futures. But there was a large group, around 30%, of the sample that was also quite worried, had fear, and even experienced anxiety about this future. And they were early adopters too. And we found them in Japan, we found them in India, in the US, in Europe. So that is also something that is present, even among early adopters around the world.
So the skepticism, again, not an hindrance to action. I think that for me is a takeaway for sure. I want to spend our last few minutes focusing a little bit more on safety when it comes to AI, and especially on this agentic future we see in front of us. And Mauricio, I was wondering, like, with this, when agents become commonplace, let's say in the coming 1 or 2 years, what do you see, what do you expect from that, from a safety perspective?
Well, definitely I see this problem getting more difficult in the sense that, of course, the attack surface for these systems becomes exponentially larger, right? So if you basically go from taking an isolated AI, right, which basically at the moment just talks to humans in a sense, for example, just a standard LLM that you might be familiar using, to, like you said before, right, AIs that start talking to other AIs, right, rather than just to quote unquote dumb or deterministic tools, then the attack surface for these systems becomes exponentially larger, and that's of course a concern. I think it will be much more of a speed game in the future. It's really going to be much more of an arms race between the attackers and defenders. Essentially, you want to fight fire with fire. So as soon as you have your first AI bot there that is explicitly trained on penetration testing for to get past firewalls and things like that, then you're basically, this forces the defenders to also use something similar, right? And so you have this race that goes on. And so I kind of see that in the relatively near future. I think we're going to have to basically start to tackle the problems that arise from the scale of this idea and this concept. Maybe less so the creativity or the novelty of the attacks, although this might change rather quickly. Perhaps Daniel actually could also comment there in the future, how he sees this developing, right? But I think in terms of what we can do, and in particular the defense mechanisms that we can employ, I think it's quite clear that in industry, you certainly have this siloing effect, right, on the defense side. As in, like, if you want to train an AI on defenses in the cybersecurity world, you of course don't want to let all the world know of how your particular company has been attacked and where the weak points are. But at some point, this information becomes siloed, and we can't sort of like jointly learn from this. So this, I think, it really motivates the topics.
I have to cut you off there because our time is running out. This section.
No worries.
Thank you very much, Mauricio. Any last 10-second comment for that?
No, I think Mauricio is completely right. And I think we're going to see within the security sector a huge push to more and more full automation, because we need that to cut down the time. And we're going to use AI to fight AI. That's the only option we have, basically.
Yes. So thank you very much, Rebecca and Mauricio. Happy to have you joined our conversation. And we are swiftly moving on to the next point in our agenda, when we'll switch it up and talk a little bit about the implications for business strategy. And with us to sort that topic out is Oskar Tekström, who is the Chief Scientist at Sana. So very welcome to you, Oskar.
Yeah, so thank you. Oskar from Sana. I want to talk about the path to enterprise AI, or AGI, artificial general intelligence, and how that relates to company strategy. Just want to mention a bit about Sana. So our focus is to build a leading enterprise AGI lab. We want to do that out of Stockholm. We also have offices in other countries, but all development is focused in Stockholm. And we are like an end-to-end partner. So we build both technical platform as well as help companies to basically adopt all of this in their strategy and also in deployment and so on. And so our basically starting point here is that AI will revolutionize how we work. And we believe that this will happen across the board, and relating back to the introduction from Daniel with agents and so on, and the increased capabilities. So what we believe we will see in the next 5 to 10 years are agents that are at the level of a PhD level or top percentile in many different areas. And these agents will have multimodal interface access, so they will basically be able to do what a human can do in these areas. And they will be able to reason and use tools, and they will also be trivially parallelizable, so that means you can deploy many different copies of the same agent at a quite low marginal cost once you've set this thing up. And why do we believe this will happen? So if you look at the latest years, scale is the key driver of AI capabilities. So to the left, we see the impact of adding more training time compute, so in the pre-training phase, and how that affects the abilities of the AI systems. And to the right, we see more recent development in test time compute, seeing the same pattern. So adding more computation at test time, we see rapidly improving capabilities. So even if we don't have any further development in the next 2 years beyond just scale, we can see that we will get a big leap in abilities across the board. So this graph shows here how after the deep learning era started, we have seen about 4x increase in flops used per year. And so if you extrapolate this, which seems likely based on research by Epoch AI, we will see the similar shift that we had from GPT-2 to GPT-4. We will see the same shift from GPT-4 to what comes next, the same kind of increase order of magnitude in compute and thereby capabilities in the next 10 years. On the flip side, you also see what we're seeing, a clear pattern of cost of intelligence trending towards near zero. So this means that inference time price goes down very rapidly. And so basically any business strategy, I think, should be rooted in fundamentals. And these are, I think, the fundamentals that we have. And if you look also just from a international perspective, sorry, that's on the next slide. But yeah, so basically any strategy has to be rooted in this. But if you look at what's happening, enterprises are unprepared. So everyone almost knows or believes that this transformation will happen. Research shows that about 60% or more of jobs will be significantly impacted by AI, but still a small fraction of companies actually knows how to get started or has get started on this journey. And if you look at this from an international perspective, comparing, for example, here the EU and US, we see clear patterns of Europe not investing at the same level. So you actually see relative investments in AI and cloud investment in Europe going down compared to the US. So since scale and computation is ultimate kind of driver here, this is something that every company needs to take into account, basically, and also like politically and from a national perspective. Okay, so why is this? Why are enterprises not able to or don't know exactly how to make use of this new technology and roll it out across the organizations and change how work is done? So part of the answer is that enterprise AI is really hard. And here's 4 different factors for why that's the case. So to deploy these things, similar to how you see scale giving increased capabilities, by giving, if to really solve like fundamental problems across an enterprise, you need to be able to connect these agents with every piece of knowledge and every tool and app that is available in an organization. So if you look at the operational efficiency of companies, it very much often comes down to how many hops do you need to go to solve a problem? How many people from different areas in the companies do you need to involve to solve a problem? And so a fundamental aspect of this to make this use of this technology is to actually combine and connect all of this across the organization and make that available to humans and agents alike. And this brings us to the next complexity, which is that to do that, you need to, solve security, data governance, and privacy issues, permissioning issues, and also in a lot of industries, like the AstraZeneca presentation talked about. Basically, there's like a lot of legal implications also for a lot of companies. So you have to navigate all of this, and then you need change management, right? So you need to basically, to really leverage this across the organization, every employee, every function in the company needs to rethink and reconsider how work is done to be able to take use of this realize the full potential of this technology. And another aspect here is that things are moving so fast, and this is hard, right? Because you want your strategy and how you deploy these things to be rooted in kind of the fundamentals and foundations. And when the world is changing so fast, if you plan for make a strategy based on where we are today, you're bound to fail. You basically need to look at where things are heading and sort of catch the ball where it's landing and not where you're standing today. And just concretely, it's shown that just getting more than something like 30% productivity improvements at an enterprise scale remains very challenging. And there's 3 pieces to this, coming back to also what I talked on the previous slide. So one is this whole integration of enterprise knowledge. So the challenge here is bridging, all different documents from different diverse systems and integrations, getting them together, putting the legal frameworks into place so that you can share the information in the ways you need to share them to make effective use of these systems. You also need to, I think, to get people to use this across the organization, you need to deploy these tools where people are. You need to basically have an UI kind of for AI where you can gradually roll these things out and make sure that people actually understand how this technology works and can use it and kind of interact with these things in a way. I think so. This is similar, I think, to how the early digitization issues we faced, where we had to reskill basically the whole organization in how to use computers. So it's similar. You're gonna have to reskill everyone in how to actually use these AI systems. And then that also come down to the change management, not by solving that with technology, but solving that on the people side, making sure that people are trained, making sure that people feel safe and secure and can use this and understand how the systems work so that they can interact with them effectively, not turning everyone into an AI engineer. So on the technical side, what we're doing is we build this platform where you can solve all of these technical challenges of integrating all your knowledge, setting up all your agents, training the agents, customizing them, making it work for you. And that's one aspect of it. And then on the rollout side, we also enable you to deploy this gradually across the organization. So we have this 4-step framework, which I think is quite useful. So on the first step here is to just be able to, get all your information accessible across the organization. So that's more or less just semantic enterprise search. The second is inform. So roughly translating to RAG systems, right? So basically you use the first retrieval solution, and then you can not only just give users the documents they need, but you can actually give them the information they need to solve a particular task, help them with simple data analysis and so on. Third here is the act, where you actually start automating workflows, maybe then often doing that gradually also by having the human in the loop, so that the AI agents can ask for help when needed, ask for clarification, but then gradually solve more and more complex tasks for you. And then finally, this is also was nice to see in the AstraZeneca presentation on the decision front, having AI agents gradually starting to also adapt and decide autonomously where those decisions can be made. So yeah, I think this is kind of the framework for to use to effectively roll out and change how people work with agents across the whole organization. And so yeah, I want to end there basically.
Thank you very much, Oscar. And of course, we have a couple of questions for you as well. But before that, I just wanted to see, and what are your thoughts on this, Daniel?
Yeah, I think one of the key points on one of the slides was basically enterprise AI is hard. I 100% agree. It's often quite a lot of work to be done. It's difficult to get everything right, but it's time to start working on it in many, many cases, I think, because if you don't, someone else will. And these things are going to be extremely capable, especially like if we go back to AstraZeneca and Magnus, when you have this systemic view and things actually interacting together, it's way more beneficial than having one single agent or something like that. But a quick question to you, Oscar. So in your presentations, when do you hope to have, now you had a graph on training time and capability and testing time and capability. When will you have a graph saying agent scale and capability or something like that?
Yeah, I think we already see that for information retrieval, for example. If you spend more time on the retrieval, your search gets better as well. And I think you see that across the board. Like it's just in the first agent, when we started working with agents, it was, it seems just like, okay, now you give an LLM a tool. But the real power is when you then see this agent running like 10 different steps to solve an end-to-end complex problem, and then making a decision when it doesn't have a piece of data, revising its strategy, and like, oh, maybe I should look for this statistic on the web instead of your internal data, because that seems where I could find it. Then it finds that, creates the plot for you, writes the memo, and it's just a completely different game then. So I think you will get this combinatorial, like similar to exponential growth. I mean, combinatorial growth is like it's faster, right? So once you start to combine all these different tools, you get like even more capabilities, I think.
Yeah.
Thank you. And I'm also thinking about this, it being hard with enterprise AI. And I'm thinking about all the inertia that is in our organizations, not to mention the public sector where it takes time. So what do you think the most important factors in the companies you see moving out of their inertia and getting their gears going? What differentiates them from the rest?
Clearly, you need the very top of the company to be completely bought in. Like once you have that, you see a tremendous momentum. I think that's one aspect of it. And that means also that you need to go quite big. So I think similar to these scaling laws, right? You add more compute and things start going up. If you stay like too low on your investment, you're gonna be like at that flat line. It's not gonna take off. So I think that's part of it also. Companies that go all in. That doesn't mean you go all in across the whole company from the start necessarily. You can also go all in, but you have to go all in some use case. If you go in like 10% across the board, maybe you will get slightly faster at writing emails. Maybe you'll get slightly better at finding something, but it's not going to unlock like completely different capabilities. So I think that's one of the key differentiators.
So to boldly invest with care, essentially, is what I'm hearing.
Yeah.
Wonderful. And I think it's time for us to move on to the next agenda point. So thank you very much, Oscar. We will invite you back shortly into this event. But for now, we will change the topic again. And we're going to invite Hanna Biras from Akavia. And Hanna, you are the expert on lifelong learning and the impact of AI on work life. Quite the title. And you work at Akavia, which is the trade union for university-educated professionals. So very welcome to you, Hanna.
Thank you so much.
And together with Daniel, our topic now is to discuss essentially the shifts on the job market and the impact of AI. So we can just, begin from the beginning. Changes in the job market, of course, is not new. Like many of the jobs that existed in the 60s are, not even heard of currently. So what do you think is different now? Why is this such an important shift, and how does it differ from previous shifts? Go ahead, Hanna.
Well, I think there are two main differences, and one being, of course, the speed in this shift. We're seeing it move very, very fast. And I think also, to a large extent, we see different groups being affected in this change. We've seen earlier automation processes in the job market, but now we see this transformation also affecting highly educated individuals. So to a large extent, that is members in Akavia. And this, I think, is something that we need to address in a new way, because a lot of our members are used to having a very stable place in the job market. They have a long education, they've never been struggling to find work, and now they need to think about their future in the job market, I think, from another perspective.
How about you, Daniel?
Yeah, I definitely agree with that. I think we're going to see some shifts when we implement these larger scale systemic AI systems. Of course, I don't think the workforce will be, you know, completely displaced or out of jobs or anything like that. But of course, it will create quite new roles, basically, where a lot of the sort of what we perceived as cognitive work and intellectual work before will be taken care of these machines. And of course, that's going to be a huge shift. But I do not, for example, necessarily see a level, and this might actually be a challenge, you know. We talked about earlier about trust, and coming from the kind of business that I'm working with right now, a lot of the work with these kinds of systems right now is sort of trust but verify, so that they actually output the right thing. And to do that, you need a very high level of expertise, basically, so that you can actually verify what these systems output. But of course, the way of working with them will be very, very different. And I'm a little bit, not concerned, but interested in how do we build the next generation experts that can actually verify the outputs and control these systems and so on.
Yeah, and I think that's a very interesting point. Yes, go ahead, Hannah.
Can I just, on that note, say that I'm sure many of you have seen the recent Microsoft study looking at the impact of Gen I on critical thinking that came just recently. And I think that's such an interesting point, that one of the things that you actually train as an academic professional is your ability of critical thinking. So how do we ensure that the workforce of tomorrow is still training their ability of critical thinking when we have systems that do a lot of things that we used to be doing ourselves? I think that's a key factor to take with us.
Definitely. So how do you see companies like adapting to that shift? Are we actually geared for it in Sweden?
Well, I would say that we have a superpower in Sweden and also to some extent in the other Nordic countries. And that is the way which we organize the job market with a very high union density. And we have a cooperation between employers and workers that are unheard of in many parts of the world. So I think that sometimes we look at the Swedish model and we say, oh, we have so much regulation that will slow us down. But my view is more that this is our superpower. We have a way of organizing the job market that has made us successful in handling earlier transformations in the job market. And I'm sure that we will do that this time around as well.
Would you agree? Is regulation to our advantage or to our detriment, Daniel?
A bit of both, I'm sure. It's I do often get the sense that we tend to over-regulate things, but again, I do also think that in Sweden and in Europe in particular, there is sometimes the sense of we use regulation and uncertainty about regulation as an excuse not to do things, and that we need to get rid of. You know, we can absolutely innovate and be compliant with these things. So I think it's a lot of approach and culture and so on in how we view these kinds of regulations. They cannot be an excuse to not do anything. That's
So, Hannah, I believe you might have a little bit of interesting statistics for us, because I'm kind of curious on what the sentiment is of the Swedish workers. How worried are they? How do they feel about this transition?
Yeah, so just to be super clear, I won't be able to speak for the entire Swedish workforce, but I would represent the, Akavia members, which are highly educated professionals. And of course, we have 145,000 members, and among them, there are 145,000 different views of this transformation. But in general, I would say that our members are more curious than worried. Approximately 1 in 10 are worried about losing their jobs, so not very many of them. And in general, they are very active in their upskilling and very eager to start using AI in their jobs. So I think they're curious and they want to start working with AI, but I think they also need their employers to start educating them. And Unfortunately, we see that in some workplaces, but not across the board in that pace that we would like it to happen.
So I think that is a great news, because in many of the research we see, many of the statistics presented, Sweden is lagging behind, but clearly that's not from the people. There's a push from below.
I think so. And of course, we see differences between member groups. I mean, we have 6 different professions. So there's differences, of course, and we also see some differences between private and public sector, with some members in the public sector being more risk,
Averse?
yes, and more skeptical. But I think also a lot of our members, they have a big responsibility on their shoulders, and they're very eager to make things right. They want to be done the right way, and they feel this big responsibility. So I think that's important to remember when we look at these figures as well.
Thank you for that. So I'm kind of curious for us to speculate a little bit, like how turbulent will this transition be? How do we see kind of the future on the Swedish or global, for that matter, job market? How is AI going to affect us?
Yeah.
Feel free to go crazy.
Well, I think important perspective here is that there is a big difference between the Swedish job market and other countries' job markets and globally, in that way that we usually have a more orderly way of doing things in the job market. So, for example, 2 years ago, we got a new student finance system, which is in Swedish called omställningsstudiestödet. This, I think, is a great opportunity for workers to reskill and upskill. And it's also a good example on how employer organizations and unions work together to be able to make new systems for reskilling and upskilling in the job market. So how messy will it be and how fast will it go? Maybe Daniel can answer the question on speed, and I can answer on messy. I hope not too messy, because we've seen the big transitions before, and we've been able to handle it in a good way. So my view is that this will not be messy, but it might go very, very fast.
Yeah.
Can we handle speed without messiness and turbulence?
Perhaps, but I do think, yes, it will be pretty fast. We will see relatively quick changes, but again, coming back to some earlier presentations, enterprise AI is hard, and building these systems that AstraZeneca wants to build and are surely capable of building, it will take years of actually building them, because there is so much engineering and data engineering work, etc., etc., etc. So it will not change overnight, basically. But I think in the meantime, to prevent that we don't have a mess in 5 years or 10 years, something like that, I think what you brought up earlier as well. Make sure that we still have educated human experts, critical thinkers, etc., etc., so that we do not lose that capability.
Wonderful. I have one last question for you, Hannah, a quick one that is. What can the individual do to stay relevant on the job market, according to you?
Well, I think that the main thing is to don't be scared, be prepared instead. And I would say also that take advantage of the opportunities that we have. For example, contact your transition organization, which a lot of people are having access to, and ask them what kind of support you can get in reskilling and upskilling for the future job market.
Wonderful. Thank you very much for your contribution, Hannah.
Thank you.
And once again, we're moving on. Time has come for the final discussion of the day, and that is the one of geopolitics and AI. And for that, we will re-welcome Oscar, who you previously got to know, and we will also welcome Anna Topol, who is the Chief Technology Officer and also Distinguished Engineer responsible for client experiences at IBM. Very welcome to you, Anna.
Thank you. So nice to be with you. Thank you for inviting.
Yes, all the way from the States. And I actually want to begin to address you, Anna, and ask you, from your perspective, being European, working and living in the America, and at a huge global company, it's quite a unique point of view. So we have, seen this super rapid pace of AI advancements, and recently the arrival of Chinese models such as DeepSeek. What shifts do you foresee on a global scale, from economics and labor impacts to shifts in international power dynamics? Big question.
I was going to say quite a loaded question. Thank you. So maybe I will chat. I will do my own AI assistant. I will do a little agents, one at a time. So if you look at the DeepSeek announcements, as the technologies, I was just simply excited about. I'm just going to state, right? Because for me, this is validating the comments IBM's been making for a while, that as technology matures, your price point starts to change, right? And I think that's what we wanted to see. And we strongly believe that, yes, we will have large models. We will continue to invest with them, but purpose-focused, smaller models will be as effective, and they will be cheaper, and therefore democratization of AI now is here. And I think that was an incredibly a positive outcome of the debates and the discussions, right? As the new models are, by the way, the new models are entering market, on the daily basis, right? But you have sometimes a bigger discussions than at other times. So now going back to your questions about economics, I think that's huge. I think till now, and I mean, we've seen in the Oscar in your comments, right? The more we train the models, the better they are. The more we work on inferences, the better they are. The more we work on testing, right? All those things make the models better, but the price points for those actions that we need to take to deploy models will be lower. It's not only that we are investing in new models themselves, new techniques, new architectures, there's a lot of new memories for models, all different things, but we also going to have new hardware. It's not going to be just CPUs and GPUs. We'll have other accelerators, right? And the hardware is already coming to the market too. And so inference will be done on different hardware than training potentially and so forth. So that's from geo-specific economics, that's really good. And the question is, how quickly those new capabilities can be brought across the world. And I just wanted to state that, we are living in a world of web and information instantly being delivered to all of us, which means there's a lot of smart people across the world that takes the next innovation and engineer and, and semi-improve on it, right? Being the first to market is very difficult, and that sometimes takes time. But democratizing technology is what we, are very good at.
Thank you. Any comment on that, Oscar?
Yeah, I agree with the excitement from a scientific engineering perspective. I also agree with the democratization aspect and also cost savings and energy efficiency and so on in hardware. But I think one way to view the DeepSeek thing, right, is that now you can actually train even larger models on even more data, right? Because now we're getting more efficiencies. And they just released a paper yesterday or the day before of a sparse attention model, right, where you can basically get 11 times faster forward passes and backwards passes and inference passes. So that means now you can train on 10 times more compute. So I do think, the way we approach this is basically by, I think there's going to be you have recipes. So a mistake that many people have made in the past is you train a small model from scratch by assembling some data and you start to train a small model. The answer is to take the biggest model you can get, then distill it down to capable models that can do very specific things, because that's how you get the best performance. And that is turning into a recipe, right? Using synthetic data and distillation techniques. But yeah, overall, I share the same sentiment as Anna.
And what I think would be interesting to see as well, there's so much talk about China and the US. What do you think will be or should be Europe and Sweden's role in all of this? We're going to start with Anna.
All right. I think we talk about US. First, let's be honest. that's where the technology started. So of course, early start is very important. We've seen it historically was followed by UK and Japan. You've seen those countries developing quickly. I think if you look for if you think about readiness, because I think this is the key question that we're answering from the geopolitical scope. If we looked at 2021 and we looked at how many countries had strategies ready, there was 44 countries with ready strategies or policies or documents that stated the intent, and most of them, I call them, were the high income countries. But only, this is 2021, only in 2024, you have over 180 countries that, and follow with both the low and middle income countries now stating what they're gonna do. And I think that is truly huge. That is truly huge. And for me, it's how we gonna get to the point where AI is ubiquitous like the phones. Part of it, when we look at what is being evaluated from the readiness point of view, is of course the government's readiness. We talked about it the same as I think Maurizio commented, or somebody, that the organizations move. I think Oscar, you actually did it. That if the leadership organization is for it, right, then the organization move faster. With the governments is the same, right? You have to have the leadership, then you have to have investments, but then you also see what is currently providing your benefits. In US, it's technology sector. In US, of course, it's a technology sector, maturity, and this capacity for innovation in general. And we do have infrastructure. If you look at the new arrivals, so if you look at a country like Brazil, they really have been for years investing in digitalization. If you are, in their case, it's agriculture, and they've been working on ability to share data, to benefit various communities by having common knowledge. And I think every country will find something that is the core of their capabilities that they need to build upon. I think we commented, Mauritius commented about Japan, passion and almost love of robotics, right? So I think each country will have the ability to succeed if they do what we mentioned before, focus on one thing that is really the winning, successful path. Country like Singapore focuses on data sharing, right? Something that is important to them from the private policy point of view, and speed is sharing data. And so I think that's what we need to really go for. And last one, since you mentioned Europe and Sweden, I'm going to say it was mentioned. Yes, you could be sensitive and asking yourself how trusting the AI is, but you need to try. You can be skeptical, but you have to test it, right? And so just like you said, Daniel, we have to just deploying AI. We have to test it. We have to just keep going.
Yeah. And I think you mentioned so many interesting points. It raises quite a lot more questions. I want to address to you, Daniel. I think it's lovely to expand beyond these Western usual suspects, and talk a little bit about the BRICS countries and African countries.
Absolutely.
How will they be affected, and what are they doing?
I do not have a full grasp of what they are actually doing. I'm very sorry about that, but I really do think that they should perhaps be in the conversation more. We have some, for example, global associations around AI, like GPI and stuff like that. I would love to see more engagement and more invitations to these kinds of countries and so on, because their use might not look exactly like ours. And if we take something such as, I'm going to say simple, although they're not, such as LLMs and guardrailing them and things like that, that might look different if you're deploying things with medical services and so on in Africa, where you absolutely need these things, compared to, for example, Europe and so on and so on. So I think we really need to bring them into the conversation. But I do also think that for many cases in these countries, they have sort of an actual way of possibility to actually leapfrog us in the use of just like they sort of skipped some of the fixed phone networks and stuff like that. They will sort of skip some of the stuff that we have in digitalization in healthcare, etc., 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 because they can move to this AI agentic future immediately, basically.
No legacy.
Yes,
exactly. Thank you for that answer. And Oscar, I actually have a question for you as well. Regarding open source, which is slightly different, but we have seen, DeepSeek is open source, Meta is heavily invested in open source, and now even OpenAI recently, Sam Altman said that he might release one of their models as open source. What do you think we'll see in this kind of back and forth between open source and closed source? What will it entail?
Where not entirely sure. It depends a bit on. So I mean, one thing that started this open source movement, we didn't start it, but really made it actually get us to a place where open source models were on par with the best closed source models. That's because Meta, right? That Mark Zuckerberg decided that we will do Llama. Now Llama is kind of falling behind DeepSeek and others, right? And they apparently have internally a war room set up now so that they can catch up. But so that's kind of the risk, right, when you do this publicly. But I think the risk is there even for closed source companies. And what's happening now, right, the people working on these models, it's a small group of people still. They move around between the companies. So the closed source strategy is not really working for these companies, I think. The technologies are shared. And as DeepSeek showed, they publish kind of the recipe now that anyone can use as long as you have the resources in terms of computation to build a model of similar capabilities. We'll see what happens with like XAI and Elon Musk, right? Because they are investing heavily, and in 1.5 years since inception, now released Grok 3, which is beating OpenAI's current best models. We'll see in a few weeks if that carries over, right? But from a European standpoint, I think it's pretty interesting. We have Hugging Face rooted in France and Mistral, which are two big players in open source. And yeah, I think if we need open source, because I think it will just make the development faster. We will get more capabilities faster. You see this now from OpenAI's 01 closed release, but on top of the recipes from DeepSeek, now academia is also getting the information they need to be able to focus on the right research, and that will just accelerate the progress. So yeah, open source will be vital, I think, to progress.
And igniting innovation, it sounds like. Wonderful. Yeah. So it sounds to me like, all these shifts, so much hype going on, so much talk. The future is quite uncertain. And I think that's hard for organizations to navigate in. So what do you guys think organizations should kind of focus on in all of this news flow that's happening? What should they do and what should they focus on? And we start with Anna, a short answer.
I will comment what Hannah commented on upskilling, and skills. And I will just state that it doesn't matter if you're a government organization. As a government, you have your data center, you have your cybersecurity software people who create applications for citizens, or if you are a business company or your education, everyone will need those skills. This is like a common need for all of us. And therefore, we really do need to invest more in skills. And
I
just wanted to go ahead.
We'll have to cut you up. So sorry. Same question for Daniel, a quick one.
I do believe, similarly, we need to focus on skills, we need to focus on innovation, and we need to build. That's really what we need to do. Wonderful.
Last comment from you as well, Oscar.
Ride the waves of the foundation model. So don't try to reinvent everything, start from scratch. Ride the waves, just like be open, pick the best model, a new better model comes out every week. Set yourself up so that you can make full use of that, and build and focus on building the data sharing capabilities, having everything actually available to the model so that you can utilize the capabilities to the max.
Thank you very much. It's been a pleasure to have you all here, and it is time for us to wrap up this event a little bit. And I do want to ask you, Daniel, what have your main takeaways been?
I think the main takeaways is basically these kinds of systems are here. They're starting to be put into use. at scale, and they're difficult, but we don't have a choice, basically. We need to start building these systems for our own sake and for our companies and organizations' sake.
Wonderful. And how fast is this shift going to happen?
It's very difficult to say, right? I think that you can perhaps break it down in a few different time frames. I think we're going to see companies building these types of very capable internal agentic systems relatively quickly. You're going to add on to human capabilities and so on even more quickly, perhaps. But the full system with agents talking about lots of things across lots of different organizations and so on, that I think is a few years into the future. We're going to basically just have to build and try and see what works.
Wonderful. Thank you very much. And with this being said, I can imagine that some of you might want to watch this again or send it to someone you work with or associated with. We do record this seminar, so we will post it on AI Sweden's YouTube shortly. And I know some of you have been asking questions in the chat. Unfortunately, we haven't been able to have a chat in this event. However, we do save all the questions you have for us, and we might be able to talk to you more in the comment field in the YouTube section. So with that said, I want to thank you all very much for attending, and a special thanks to all our panelists and keynote speakers. It's been wonderful, and I hope to see you again next year. Goodbye from me and Daniel.